In this second lecture on chapter 24, I'm going to focus on metabolism and energy balance. So the food that we take in and eat has a certain amount of energy in it, stored in its chemical bonds, which we then break down, those chemical bonds, and we liberate the energy from those bonds, and then we're going to take that energy and use it in other ways in the body. Much of the energy we get from our foodstuffs is going to be lost as heat energy. And that's a consequence of burning any fuel. When you burn a fuel, you consume oxygen and you produce heat. The same thing happens in our body. So we lose a lot of the energy in the form of heat. Some of that energy, of course, is going to be used to produce ATP, to do molecular work. And any energy that we don't lose as heat or use immediately to do ATP or make ATP is going to get stored in the form of glycogen or fat. So the heat energy that's given off from those chemical reactions could be considered waste, but the body is going to use that heat for keeping the tissues warm so that the cell's metabolism can occur efficiently. So it's not really truly wasted. Now, if in our diet we take in just exactly the amount of energy that we need in order to sustain our normal homeostatic activities, then we would maintain a stable weight. But most of us don't do that. Most of us get more calories than we need, so we would gain weight, and in cases where we don't actually get enough, obviously we would lose weight. The body mass index, or BMI, was derived in order to take into account a person's height as well as their weight in terms of trying to determine whether somebody's at a healthy size or not. So it's not just a matter of weight, obviously. So there's this little formula here for calculating the body mass index. We multiply your weight in pounds by 705 and then divide by your height in square inches. And that'll give you some number on the BMI scale. Or you could also find one of those charts online, BMI chart, and you can just simply find your height and weight on the chart and see where you fall. So the BMI is just meant to correlate height and weight and determine whether a person is underweight or overweight or obese or at a healthy weight, etc. And obviously, being overweight carries with it many different health risks. There's an increased chance of contracting type 2 diabetes, atherosclerosis. There's a lot of low-grade systemic inflammation associated with obesity, which will lead to hardening of the arteries, high blood pressure, heart disease, etc. Our energy intake is under the control of various factors. Sensory information from the gut. Whoa, that's not supposed to happen. Sensory information from the gut, for instance. The blood levels of nutrients circulating around in the body. Hormones all have a lot of control or influence over our energy intake. So in the short term, the vagus nerve, cranial nerve number 10, allows the gut to communicate with the brain. Signals about protein content travel on the vagus nerve. The higher the protein content of the meal, the more full one would feel. Also, the stretch in the duodenum, the first part of the small intestine. The vagus nerve relays information about how much food is in the duodenum, and both these things are going to suppress appetite. Chemoreceptors pick up information about blood levels of nutrients, so plenty of glucose, amino acids, or fatty acids are going to depress appetite in the short term. And there are various hormones that influence appetite in the short term. Insulin, which is released after a meal in response to high blood glucose levels. CCK, cholecystokinin, comes from the gut. It's produced by the duodenum. When the duodenum is stretched with food, CCK will be produced, and it tells the stomach to stop producing gastric juices. When the stomach is empty, it's going to produce ghrelin, which is one of our main appetite-stimulating hormones. Ghrelin is produced by an empty stomach, and it peaks just before meal mealtime. And glucagon has the opposite effect of insulin. We have lots of glucagon when we don't have much glucose in the bloodstream, so that's going to stimulate appetite. So there are various hormones that influence our feeding behavior in the short term. Leptin is a hormone with long-term control over feeding behavior. Leptin is secreted by fat cells, and there's a correlation between leptin levels and an individual's fat stores. So the more total fat there is, the more leptin there is circulating around in the bloodstream. It's believed that leptin helps to prevent against excessive loss of fat during times of starvation. It was once thought that leptin would be a cure for obesity, and then it seemed initially to act as an appetite suppressant. But it turns out that, again, there's a correlation between leptin levels and fat stores. So people who are obese have high leptin levels. So it doesn't seem to be suppressing appetite because people can develop resistance to leptin, much in the same way that some people develop resistance to insulin in diabetes, type 2 diabetes. So the current theory again is that leptin levels act to help preserve fat stores in times of starvation. And there are many other factors that will influence feeding behavior as well. A person's emotional state has a lot to do with hunger. Our bacterial flora even get to have a say. Many people on medications which might have side effects that would increase or suppress appetite. So there are many different things that can influence our feeding behaviors. Now I want to talk just a little bit about metabolic rates, which measure body's energy output. That is the sum of the heat produced by chemical reactions and mechanical work done by the body. And mechanical work is referred mostly to skeletal muscle movements. One can measure a person's metabolic rate using a respirometer pretty efficiently. That measures the oxygen consumption, which correlates with their metabolism. And hopefully that makes sense because when we burn fuel, we require oxygen to burn any kind of fuel. The basal metabolic rate measures the amount of energy that the body needs to perform just its most vital activities, those that are necessary for life. And so basal metabolic rate, or BMR, is going to be measured while a person is in a state of relaxation, long after a meal, reclining, chilled out, comfortable temperature, all that sort of thing. How much energy a person needs to maintain all those vital activities varies greatly from body to body. Some of the factors that can influence basal metabolic rate include gender. Males have a higher metabolic rate than females do in general. Also, age affects BMR greatly. So as we age, our metabolic rate declines, unfortunately. In the short term, factors like body temperature and stress influence basal metabolic rate. Increased temperature is going to increase the metabolism. Stress will increase metabolism as well. And remember, the thyroid gland produces thyroxine, thyroid hormone, and that is the body's major hormone that's going to control metabolic rate. Now, total metabolic rate considers all the body's activities, not just those that are essential for life. So this would include your basal metabolic rate and any other activities. And as it turns out, in most folks, the basal metabolic rate makes up most of the total metabolic rate much of the time. But if we are exercising or something like that, use of skeletal muscle is going to greatly increase our total metabolic rate. And there's also a big jump in total metabolic rate immediately after a meal, and a lot of that has to do with the liver metabolizing the nutrients from the meal. A person's metabolic rate has a great influence, of course, over their overall health. Many of us either have or are at risk of having in the future so-called metabolic syndrome, which is a group of several different conditions or symptoms. Metabolic syndrome comes with a great increase in risk of contracting heart disease and a huge increase in the incidence of type 2 diabetes. The outwardly noticeable sign of metabolic syndrome is an increase in the size of the waist. There's an accumulation of visceral fat, fat that accumulates in the abdomen rather than around the hips or the glutes. This comes along with an increase in blood levels of triglycerides, fats. There's a decrease in the good cholesterol, HDL, so-called good cholesterol, and that comes with an increase in the bad cholesterol, the LDL. Blood pressure increases, blood levels of glucose increase, which is correlated with that risk of diabetes. This guy is demonstrating the so-called apple shape associated with the metabolic syndrome. So there's an accumulation of fat in the abdomen, so-called visceral fat, rather than the deposition of subcutaneous fat around the hips, which gives rise to the so-called pear-shaped body. This apple-shaped body is associated with metabolic syndrome because that increase in the size of the waist is going to be correlated with an increase in blood glucose levels, increased insulin resistance, increased levels of blood triglycerides, decrease in good cholesterol, increase in bad cholesterol. There's an increase in hardening of the arteries there. The heart has to pump harder, so there's a greater blood pressure. And as it turns out, about a third of American adults have 3 of these 5 symptoms at least. There are drugs that can treat some of these symptoms, but diet and exercise are perhaps the best approach to deal with metabolic syndrome.